Alright, in this video I'm going to be showing you the solution to Leetcode Problem 61, rotate list. This is listed as a medium problem. Given the head of a linked list, rotate the list to the right by k places. So we're given a linked list of 1, 2, 3, 4, 5 and k equaling 2, and we rotate it twice to the right so that the new head is 4, then 5, then 1, 2, 3. Another solution or another example here, given a linked list 0, 1, 2, rotate it 4 times. So the rotation occurs, first rotation, 2 now becomes the head, then 1 becomes the head, then 0 becomes the head, and notice how we restarted from our initial state, 0, 1, 2, back to 0, 1, 2, and then 2, 0, 1 is the final state and we return that. We're doing an in-place rotation here, okay? Or at least we're attempting to do that to save in memory space. Our constraints here, number of nodes in the list is in the range from 0 to 500. The node value doesn't really matter in this problem, and the k can be basically between 0 and 2 times 10 to the 9, so very large k. But do notice that the length of the list, the linked list, at most is going to be 500 items. So that's pretty small compared to some of the other problems we've seen. So we can actually use this to our advantage because we know that there's a constant value or a finite amount. So you can do 500 iterations very quickly and not have to worry about that scaling up more in terms of like your operations, right? So if we go through the question again, we see we're trying to basically take the second to the last item and make it the first item, or the k to the last item and make it the head. If k is larger than the list, then we just subtract the length of the list from k, or we can do, if k is like a massive number like 10,000 and the list is only 5, well, we do a division. We can do like a modulus and basically get our remainder, and that's what we use to do our rotation. So in the example here, k is 4, which is larger than the list. So after we do 3 rotations, we're back to where we started, and then we only need to do 1 rotation. So we can do some quick math to determine what is the actual amount of rotations we really need to do. And in this case, it's only 1 rotation, and that gives us the final result. So keep that in mind as we go through this problem. And also, it helped me to kind of think of this, instead of thinking of this problem as a linked list, think of this as an array. And what would you do if this were an array? You would just simply slice the array at the k to the last item, right? So if we were given this as an array and then we say, take these last 2 items off and move them to the front, that's essentially all we're doing. We're making the front of our list, this k to the last item, and then everything else is the same. So I've written up the code here. I'm not going to go ahead and type it out, but I've already written it here. And I've got a helper function that I've added here, which essentially just gives us the length of the linked list, as well as a reference to the last node in the linked list. So if I run this function, it'll give us 5, and it'll give us reference to this last item in the linked list. And that's important because we don't want to have to traverse the list fully twice if we don't have to. We do have to traverse it once to figure out the length, but then we can traverse it only up to the number of items, or the length of the list minus k, and then we'll get our reference to where the new end will be, and then we basically do a little swap and move these over. And so that's all we're doing here is we're getting that reference to the last node, we're getting the length of the entire linked list, we're doing a little modulus division here to reduce k down to what the number should be eventually, which in this case, if we do it on 4 and our linked list length is 3, if we do 4 mod 3, we get 1. So this is a simple way of kind of cheating this very large number that we'll see here. This might be, 10,000 or whatever. We just quickly reduce it down to some number in this range. And then we can go ahead and run the rest of our operations. Then we simply count, or we get a reference to k to the last item minus 1 in this list. So we actually get reference to this item because we're looking for, the second to the last item in the list, but we actually have to get reference to this one to essentially null its pointer, or its reference, its pointer to this one. So we null its pointer, so it becomes the end. We keep reference to this one, we make it the front, and we also already have reference to this one through this helper function, and we point it to 1, and then we return that. And so then our return looks like this. And so, that's pretty much it. We're going and checking getting the length of the list and the last node in the list, the linked list, and we're reducing k down to a number within this range from 0 to 500, and we're doing our swap at the end here. All right, so let's go ahead and submit this. And there you have it. That's a valid solution. So go ahead and take a look at this code. Feel free to use it. And leave a comment if you have any questions on the solution I provided. Otherwise, thank you for watching.